Time for another DraftPhysics.com, debatephysics.com also. And, there's a lot to discuss about physics, and apparently very few people wish to engage in a conversation. And so physics does create these, fake debates. They claim that there's going to be some kind of, call it a full debate, and it's not really a debate. It's just like-minded people arguing about tiny differences in their Catholicism, Orthodox versus modern Catholic, that kind of crap. And so it really doesn't get anywhere. So anyway, Sabine Hossenfelder does a lot of these shows. And so I figure I might as well keep picking on her because, she's becoming a spokesperson for physics. And it's crap. And it's completely underthought, underprocessed. It's like they don't even really think about what they're arguing in defense of. Just as the kinetic energy formula basically overtly states that it does take 25 times the force or fuel to move something 5 times as fast. Or that something going 5 times faster, something moving 5 times faster, can actually do 25 times the work. It can express 25 times the energy into the universe. And they have nothing as evidence. And they have all kinds of counter evidence where bowlers, for example, don't use a lighter bowling ball, even though they could double, just by cutting the weight of the ball in half, the amount of energy they could put into the pins by physics's theory. And it's obviously not something they can find. And lots of other pieces of evidence that I've gone over and over. And so we're going to talk about gravity this time, and stuff I didn't occur to me. And, because, you can't, there's a lot to think through. The subject is deep. It's physics. So there's a lot to consider. And people just don't think about what is being said, and they assume that the obvious counter-arguments would have already been made. And yes, that's a wrong assumption because people just haven't thought about it. So I guess I'll play what she's saying after I make my statement, okay, about what has occurred to me regarding gravity. Why any notion that it's not a force, that it's not an active, real thing. It's not a bent geodesic. It's an actual physical process that has, you can't get around the fact that it's real energy that it creates, and that energy has to be reused in the universe. It can't just dissipate out of the universe. So anyway, and then the second argument is about the bending of light, which is stated to be something that's a possible thing to do, that you can somehow force a beam of photon to essentially take on more than one velocity, move in more than one direction at the same time. And the argument is that no, all the forces are one-dimensional objects, and they can't have two momentums. They can't move like a baseball. They can't be launched and be bent by gravity, because that creates more energy when it hits the ground. If I just drop something and I shoot something and it hits the ground, the thing I shot is going to have more energy when it hits the ground because it has both motions. Okay. It's going to impose both motions on the ground when it hits it. And both momentums, frankly, but in combination. So it's not going to be, you don't get to add both of them. You recognize that they are combined. Yeah, well, that's an open question. It depends on how you catch it, I guess. Because really both momentums are going to be real. and both are going to be consumed by the thing. The point is that the velocity change is not something light can do. So as I'm talking about light, I guess I'll get to that argument first. So the idea of light bending around a gravitational body. Okay, you're just saying, so light comes in going straight and somehow it is bent and it goes in some new direction. Well, to do that, there's an obligation, or what makes it possible for something to orbit. Okay, so let's just say you put something in an orbit around another body. I guess I have to draw this big enough. You could sort of understand that there's two things. There's the velocity going this way and then the added velocity going down. And that creates this diagonal line that you would say would be the new trajectory, and that trajectory would have a higher velocity because it's a longer line in the same time. So you've increased the velocity of something by bending it into something. But the catch is the very next motion, okay, where this is now your new trajectory and now you're going to push it down into gravity. This line opposes that line. That is, it has an element going this way. So your first line was going this way, your velocity. And now you essentially have a new element that's essentially opposing the new trajectory. So your trajectory now isn't parallel to the surface. You're not going tangential to the surface anymore. You're bent. And now you're tangential to a new surface. And that new surface has an element going opposing. You can sort of say it's this kind of shape. So you're going to be bending down into the earth against, okay, with this element, this little bit of element, this velocity against this velocity. And that little element takes away the velocity you got, the extra velocity you got by doing this hypotenuse that's a longer line. So you got a little extra velocity by adding the energy. But now on the very next turn, you're going to lose that velocity because there's an element against that motion. And so your velocity is going to go back to what it was originally. So that's why something can orbit at a stable velocity and not gain velocity from the constant bending of the gravity. But the catch is when you leave, okay, there's not going to be any compensation for that last bit of bending. So the fact that you're still getting bent, your trajectory isn't getting turned as much. It's not enough of an opposing force, and therefore you're still going to retain a little extra velocity. So how to best say that? You can't just turn gravity off. So the point is, if you could just immediately turn it off like breaking a string, well, then you would keep the velocity you had and you wouldn't be able to increase it or decrease it. But the fact that you are going to gradually leave the gravitational body means that your velocity does have to change. And you couldn't have a constant speed of light if light was bent by gravity, is the simple argument. And that light could never get into an orbit because it would have to constantly be changing its speed. So it's a reason, one of the many, I think, reasons to recognize that forces can't be bent by forces, and that although there is apparent evidence supporting the idea of light bending, there's no real hard evidence, and there's lots of flaws in the evidence that exists. So the lensed images from space are mathematically messy. They need dark matter. They need to put in fake gravity to make them make any sense at all because they are so non-spherical and disproportional and asymmetric. And strong gravity strong enough to bend light, would be very symmetric. Lots of arguments to make. Gravity is not a magnifying lens. It's a distorting lens because it bends more in the middle and bends less on the outside, which is exactly the opposite of a light collecting magnifier. And so the very idea that you would see images with any kind of volume of photons is theoretically impossible. So much of the stuff they see in lensed images has the same brightness as the other objects at the same distance, and they really couldn't have the same brightness because the lens can't magnify the number of photons you're viewing. All right, so lots of good reasons to doubt that. All right, but back to the more elemental reason not to buy into this idea that gravity is some kind of non-force made of some idea of just some mechanism that just happens, some bent geodesic, some bent space causes things to move or change. And the change, important changes, is that much of the change is the acquisition of velocity. They're given velocity. Something's in space and it's given velocity by gravity. So it's given energy. It has less energy if left alone without any gravity, and gravity is giving it energy by the time it hits the surface. And then every piece of matter on the surface is also still moving towards the center. You're moving towards the center, constantly trying to get there. And the only thing stopping you is the fact that the center already has a higher pressure inside of it. And so you're being forced not to go in because there's a counter pressure pushing you out that's just as strong as the gravity. It's equal. The pressure pushing you back is equal to the force pushing you down. And the pressure pushing you back is made out of the fact that there's force moving exactly in the opposite direction to the direction you're trying to move in inside of the Earth. So it already has all of these arrows, okay, all of these vectors from the convergence, all pointing in. And obviously every arrow has a counter arrow opposing it. And they're, the fact is you can't cancel energy. So something can't bang into something else and nothing happens. The energy always has to still come out. The arrow has to continue to exist. So there's no cancellation. So obviously they just keep pushing each other back and forth, and that's the nature of heat. So the center of the Earth is molten because of gravity. Gravity did it. Gravity's the cause of it. A huge amount of energy stored inside the Earth. And the reason why it's stuck there is just because it takes time to get out. So there's just always a time deficit between the energy going in and the same energy coming back out again. But we know that it is at equilibrium because we know we're sitting on the surface right on that. We're not going up and we're not going down because there's an equal amount of pressure. It's been equalized. So the pressure escaping is the same as the pressure going in. And there just happens to be, the fact is that the in stuff takes time. It has to spend time inside the Earth, okay? And so that's the imbalance that created the gravity in the first place. That's the fact that the pressure on the outside is greater than the pressure coming from the inside, because the inside pressure is one behind constantly. It's always reacting to the action of gravity. And so that's the deficit. But the fact that the important point to make is it's obviously the Earth is radiating a ton of heat Kelvin. By Kelvin circumstances, the Earth is not cold. It's really hot. It's a lot of energy. Each degree, you could say, is each degree Kelvin that you could change the Earth would be an insane amount of megatons of nuclear bombs worth of energy. To raise the temperature of the entire Earth 1 degree Kelvin would be like 1 million nuclear bombs. So it's a huge amount of energy when you say, well, the temperature of the Earth is 150 Kelvin or something. It's a gigantic amount of heat, and the interior is more like 250 or some other number. 2000, no, yeah, I have to think for a minute. The huge difference between these different ways of measuring. It's just that the Kelvin doesn't have a zero, so that's the important part. It's an absolute scale. But anyway, it doesn't have a zero you can reach, and that's because of gravity that you can't reach it. That the universe is full of this radiant heat. So the point is that gravity obviously creates heat in the earth. It creates motion in objects. The motion creates pressure. The pressure is just essentially saying, I'm pushing this way, the other piece is pushing that way. They just sit there and push each other, move each other. And that constant movement creates a tremendous amount of heat inside the earth. And the earth does radiate it. It's just that it's behind the amount of energy stored in the earth. That's how far behind it is. And it has to constantly fuel that temperature. It can't keep the temperature unless gravity keeps pushing in and creating the temperature. And so it's a gigantic amount of energy in the universe. It has to be dissipated. You know, it's dissipated back into the universe. So the very amount of force that created the heat in the earth is clearly the amount of force that eventually radiates out of the heat. So if we turned off gravity tomorrow, the earth would start cooling. All right, and it would give back this little extra amount. But the amount in space before that was also a huge amount that's constantly going in and constantly coming out because the earth is at equilibrium. So you have the same strength of force that's pushing everything into the earth is the same strength of heat that's radiating out of the earth as pressure. So you can understand there's a balance there. The very force that created the gravity is the same force it's radiating. And it's radiating into a universe that is full of other objects. And so all the other objects are in the same circumstance. We're heating them. They're heating you. That's, so everything is being bombarded by this huge amount of radiant force. It's not all in infrared. It's in radio and microwaves and infrared and visible and ultraviolet and gamma rays and x-rays, and all of those different forms of radiant force are all bombarding everything. And some of it we can see and detect with machinery, and some of it we can't because it doesn't have a sufficient frequency. It doesn't have a constant or consistent pattern that enables us to tune it in on a radio, because the frequency just keeps changing and it's different for each unit of energy is a different frequency. Well, we can't detect any of that with any of our detectors. Our detectors aren't any good at detecting something that's varying its frequency dramatically from, at 1 millisecond it's a gamma ray, the next millisecond it's a radio wave, the next millisecond it's infrared, the next millisecond is a visible photon. And so collectively it can't be interpreted as any of those things. So it remains invisible, but it's still energy impacting. It's still causing heat. And that's the truth of it. And so there's no room in there for any kind of bent space causes it, because it produces real heat, real practical force, radiation. And there's no mechanism to put radiation into some mechanism called a bent geodesic. There's only a mechanism that says, well, the radiant energy ends up hitting all the other crap in the universe. So there's an equal amount of the radiant crap, and the difference is that every material body of any kind of substance slows down the process of exchange, and that's it. It just slows it down, and that slowing it down means it's always a little bit behind. The excretion of the energy takes longer than the absorption, and that differential is what we're constantly in, and what any piece of matter in space sees is the immediate differential, that there's more coming from the outside towards the object than there is coming from the object pushing it away. So it's not at equilibrium, and it can't be at equilibrium till it gets on the surface of the earth, okay, where the matter is pushing it back out, where the force is converted into material motion, and where there is a time differential because the matter moves slower than the force. So lots of ways of explaining that. But it's a gravity is just a thermodynamic function. Everybody radiates the energy back into the universe, and that energy, that momentum, is just the same thing that pushes you into some other body. So it's all the same. The energy is, the universe is just pressurized with that radiant energy. Your cell phones, the magnetism, the electricity, the light, all of those forms of radiation are all momentum carrying, pushing force. And it pushes things into clumps. Because every time you move matter, it moves slower than the force would have gone if it didn't push the matter. So you can understand when the force is coming from space, there's no matter in its way, so it pushes you directly. But coming the other way from inside the Earth, there's a bunch of matter in the way, and the compensating force can't get to you, okay? At the same time, this force is hitting you. So you're always in that imbalance. All right, so I think that's... So just this pointing out that this simple mechanism, this simple description of gravity, it does work. And it makes sense. It's a push force. It's, not pulling. There's no magic involved. There's no spooky action. It's a quite easily understood action that you're being pushed into the Earth. You can see that the Earth is absorbing energy because that's why it's hot. So it makes perfect sense that the heat comes at the price of equilibrium. And that's why we fall towards the Earth, is because there's a lack of equilibrium created by the fact that there's a bunch of energy stuck heating the Earth. Perfectly reasonable explanation and real physics. It has a real physical function. And their science doesn't have any of that. So I'll just play some of this stuff and respond to it. But, they don't really get to the point of saying, look, their problem with their physics not matching is the fact that they have established these axioms that are just wrong. It's not bent space. It's a force. All right? It's not wave-particle duality. It's clumpy particle. I mean, even Feynman said that. And there's no wooey entanglements and superpositions or any of that stuff, because it's not. There's no interference. Forces don't interact with forces. Simple truth. They know it in every other aspect of physics. They concede that point, except when they want to do their wave-particle duality, and then they do their energy duality, which is the catastrophic flaw, where they give objects, they assign them more energy falsely. Well, they do that with photons. They think frequency means it has more energy, when no, it just means you're going to produce the effect, over a shorter period of time, but it's the same number of bullets. It's the same amount of energy to make it. It happens to be a fact that it's harder for the universe to make. It's like it's hard for us to make a machine gun that shoots bullets faster and faster because it gets hotter and hotter. That kind of thing. So there's limitations to what can be done, but it doesn't mean it takes more energy. All right, that's probably enough. I better check volumes and such here. And increase this. Should be good enough. Oh, you have to be able to see it. Yeah, there you go. Guess we can get rid of that. All right.
Thank you, and thanks everyone for being here. It's always good to be in London. So since I'm the first to get to say something, I want to say a little more about the problem that we're talking about in the first place.
So the problem is this incompatibility between quantum mechanics, this woo function where nothing has to be in any one place or any of that crap, and the fact that gravity does create this consistent force, and you can't really be in two places at the same time creating gravity in two places at the same time. So entangled particles have to be separated from gravity because they would be making gravity in all the locations they're in, and So they would, the fact is there would be no measurement problem because you'd have to make the concession that if gravity was a real force, it's de-entangled the particles. So no particle could escape de-entanglement because no particle could escape gravity. So there's lots of ways to articulate the problem, but I mean, frankly, this goes to the measurement problem directly, and it goes to this the whole idea that there's any place in the universe where you can sustain your entanglement without interacting with the rest of the universe, the force that's in the universe, without a cell phone call hitting you. There's no place to hide.
So we know of 4 different fundamental forces.
So this is the crap, where they say so. So there's only one force. That's what I'm showing you right there, and it creates charge. And so that's the elemental function, is the fact that electrons and protons are going to be moved by which one of these little force bits hits them and how they get hit. And that's all that's going to decide the motion of electrons and protons, and the motion of electrons and protons decides everything else, including gravity. So it's first the charge that causes the motion, and the charge is how the force interacts with matter. But you can't understand it as just push. It's the idea that the stuff going the speed of light, the bits of force, hit material objects and cause them to move. So in that elemental sense, you could call that gravity. But you really do need to understand that electrons and protons behave differently because there's a subtle difference in those force interactions. 2 + 2 + 3 physics. 2 kinds of force, 2 kinds of matter, 3 kinds of interaction. Reflection, absorption, and transition.
In physics, that's the electromagnetic force that most of you have
So that's just all the light and all the things we call a photon. So there's no point in saying it's electromagnetic. It's gamma rays, it's all the stuff moving the speed of light. And so it's all the stuff, and that stuff is the same stuff causing gravity. There's only one force, okay, and that's the stuff moving the speed of light. And the only distinction is the force has 2 components, just like there's 2 components to matter, electrons and protons. There's electron force and proton force, and that's all you need as an elemental beginning to start getting right answers.
Probably heard of. Then we have the strong and weak nuclear force, and
so there's no need for the strong nuclear force. So this is another argument that's so obvious and simple. So I have 2 north-facing magnets here. So the magnet has a south pole over here and a south pole over here, and here's the 2 north sides. And I'm saying, how do I get these 2 to go into each other? They refuse to go. It's incredible force. I can't get them together. I just stick, right, a south-facing. So I take a north-south magnet and just stick it right there, and those 2 move right next to each other, just the magnet in the way. So I can get them really close to each other by just sticking, the opposite pole. And the fact is, electrons and protons are the magnetic monopoles, and the fact is that if you want to get 2 protons together, you just put an electron between them, and the 2 protons won't see each other. They'll be attracted to the electron, and they'll get really close to each other. And so that's what's holding nucleuses together, is electrons and protons want to combine, in the sense that the force compels them to, because there's a lack of energy between them, and there's a doubling of the energy between electrons and protons, and a halving of the energy between their opposites. And that's why there's attraction and repulsion. But they don't understand that physics, so they can't understand any other physics. But the fact that they couldn't draw the simple conclusion that there's no need for a strong force, some made-up, bent geodesic again, some made-up, woolly, invented strong force. They just say it exists. They have no dimensions for it, no physicality for it, no mechanism for it. When the simple answer is, you want to get 2 protons close together, just stick an electron between them. And this is in the context where modern physics concedes that neutrons decay. This neutral particle decays into an electron and proton. doesn't that give it away that there are actually electrons in the nucleus? They're being carried by the proton. The proton has the electron. The electron is doing the very thing I'm describing. It's mitigating the combining of protons. It's allowing protons to get very close to each other because there's, in fact, electrons performing that simple task.
We have gravity. And the problem is that three of those forces, the electromagnetic and the two nuclear forces, have quantum properties. So
says her. Okay, so again, we're supposed to believe it because they say so. That photons are in superpositions and that electrons are in all this stuff is in some kind of bizarre lack of locality and, doesn't know where it is or where it's going.
We have some particles like electrons and quarks and gluons, stuff like this.
Yes, you say exist, but again, they have no photograph of any of this stuff, and it's all done by surmising it, out of a tiny bit of evidence. So they do an experiment called deep inelastic scattering. So I still haven't found out exactly, it's done in a linear accelerator. And this is how they invented, this whole, jargon of what happens is because they analyze this experiment where you shoot electrons at protons and see that they get deflected. And the fact is they exchange some of their energy. But the key point is again, they're measuring it by kinetic energy. They're measuring the capacity of something to do work based on the kinetic energy formula, which is exaggerating what its real energy is. So they understand there's this much went in, they only got this much out, so they have to invent an excuse for where the energy went. So they got all of their energy equations are wrong because they're all based on this fake notion that there's some reason to think squaring velocity is a good idea. Well, of course, it makes no geometric sense.
And we know that they do funny things, like they obey the uncertainty principle.
So they don't necessarily do any of these things in any way that they have proven. So this whole uncertainty nonsense, nothing obeys it. It's just the fact is we can't see electrons and protons. So again, they're just saying, they don't travel straight lines and they don't obey these geometric rules when there's no reason to think they don't. The evidence doesn't show that they don't. It just shows that we can't prove they travel in a straight line.
And be in two places at the same time, that
kind of thing. Two places at the same time. So she's going to get to that argument where she's just going to point out, well, you can't really be in two places at the same time in a gravitational field.
Kind of weird stuff. And then there's gravity, which is described by Einstein's theory of general relativity.
Right, now it's not described. So again, they keep saying it's a description, and it's just a regurgitation of the inverse square law. It's just telling you, there's this rule about how gravity gets stronger and weaker, and I could draw it as a bent geodesic, just like I can draw rays of light coming from the sun, and I could say, look, at 1 second, all of the photons will be at this location. Well, so what? I could draw a round line, an arbitrary line, and I could draw another arbitrary line, another arbitrary line. I could say, look, it's wave look-like. It's not waving. It's straight rays. You can make bullets look like a wave. You can make material objects wave. You can make... obviously, but mediums require connection. So, with discrete independent particles, but you can still make them look like, but they aren't really acting like. So this is the big problem with their physics, is these assumptions that they turned in, these kind of weak, made up guesses, and they turn them into well-established fact. And they're not well established by logic or evidence, like kinetic energy. The evidence points decidedly against rather than decidedly for.
And that theory doesn't know anything about quantum properties. And this brings up the question, if I have a particle like an electron.
It's just a convergence. Again, Einstein didn't add anything to the story. He just called, he said, where Newton didn't tell you a cause because wasn't confident about a cause. Einstein decided, well, I'll just say bent geodesic. Because the light coming from the sun is doing a bent geodesic. It's just reversed. So photons coming from the sun are doing exactly the same behavior being created, same consequence to the universe, exactly the same mechanisms in every detail. And the only difference is it's coming out instead of going in. But Einstein's addition to the story wasn't anything. He just said, let's start calling photons coming out of the sun a bent geodesic. Well, that's not why there's an inverse square law. There's an inverse square law because it's pressure coming out and spreading in 2 dimensions. And the exact opposite is happening when the force comes into the earth. It's converging in 2 dimensions. So it's exactly the same thing.
Electron that can be in 2 places at the same time.
Nonsense.
And it has a mass. And that mass generates a gravitational pull. Where does the gravitational pull go?
So the idea of whether an electron has gravity, again, the point is it really isn't. It has charge. And it's going to be moved based on its charge, not its gravity per se. So the force, it's still the force hitting the object, but the thing that creates the differential, the difference between moving towards the proton and moving away from another electron, it has to be understood as charge. So charge is what's creating the opportunity to create differentials in the field. There couldn't be any change in the universe in substance if the force didn't have this element of charge.
You'd expect that to also go to 2 places at the same time, but Einstein's theory can't make that work.
It's not Einstein's theory that can't make that work. You can't make it work because it doesn't happen, because there's no evidence of it happening. There's no, just as there's no evidence that you can make light go faster by bending it. And if it can't go faster when you know it is being bent and it must go faster, you've got a problem. Even the whole idea, if you're going to say light can be bent by gravity and then it can't be accelerated by gravity or decelerated by gravity, doesn't make any sense. If you can change its trajectory, if you can add energy to it, to bend it, how else can you bend it? Well, and you know that gravity is doing that. Gravity gives material objects momentum. It doesn't give them motion. It gives them momentum. Just motion.
Because it doesn't know anything about quantum properties. So this leaves us in this weird position where we just don't know what...
Well, and again, if gravity is a real force, okay, a real interacting mechanism, then it's interacting constantly, and there would be no opportunity for anything to be entangled because everything would be interacting with gravity. Gravity would be taking its picture. So nothing could be in a superposition, an unknown state, because there would be something photographing its position, creating a record of its position. The universe would know where it is, because gravity would be producing the signature.
The gravitational pull of an electron is. So it's a really simple question, like what's going on with the gravitational field of this electron, and we don't know.
Right. So why are you so confident about all of these statements you make in physics when you have this real problem where, your theories can't be coherent and there's these gigantic continuity gaps?
And if you ask more technically, what's the matter? It's just that those 2 theories, the quantum field theories that we use to describe particles, like
And they really don't, right? These field theories don't work because they don't know what causes charge in the first place. They don't understand the mechanism. They think it's virtual stuff, mathematically abstractions that somehow happen in the universe. The universe makes a mathematical abstraction that there's no physical mechanism.
the electron and a couple of other particles. Einstein's theory of general relativity, they're just mathematically incompatible. If we just put them together.
So Newton's theory of gravity essentially is incompatible. I mean, any rational theory about three-dimensional space and motion in those three dimensions by rules isn't consistent with Einstein's theory.
It doesn't work. But nature knows how it works.
Irritating. So obviously there's a truth. The point is how do human beings use their neural capacity to its best efficiency in terms of trying to dissect the truth out of all the noise and information provided. And I would argue these people are doing a horrible job because they're just arrogant, Borgish, bandwagon riding yahoos, okay, and they're not really doing any careful thinking before they make proclamations about reality.
So there's got to be a solution to this, and we don't know what it is.
Both your notions are wrong, okay? The whole wacky woo of quantum mechanics is nonsense, and Einstein's dopey notion that time is a dimension, a place in the universe somewhere, is also bullshit.
Many people have tried to solve this problem. What we need is a theory of quantum gravity.
No, what you need is to go backward, okay, to what you have established as a truth. So you did really good work to figure out there's electrons, and then you did pretty good work to figure out there's protons. Then you did the good work to figure out there was a neutron, and then you did the good work of figuring out the neutron is made out of an electron and proton. And obviously, those elements are the elements. All of chemistry just uses those mechanisms. There's no need for neutrinos and taus and muons and all kinds of other crap when doing elemental or useful chemistry. Because we know the atom is really just made out of the interaction between electrons and protons. And the fact is the electrons are on the outside. They're the things you can manipulate. And mostly manipulating electron force it will get you action in other objects.
That gives properties to gravity. At least that's the way that it's...
Yeah, so you have to give properties to things. So first you have to identify the things in the universe, and then you have to identify their properties. So again, the work done for electrons and protons really good, and neutrons, in terms of defining properties. But then they gave electrons spin. They gave the electrons properties there's no evidence they have. It's already enough of a job to explain charge. You don't need to waste your time talking about an electron spinning. It's just nonsense. And understanding that the force carries momentum, and the force is discrete and small, and the matter basically collects it. Like a quantity of motion, it collects a quantity of energy, and the energy means it has a differential and it can move in a direction.
It's normally put, but more generally, we need some way to resolve this discrepancy between the two theories.
Right, it's a push-averse that would resolve it. So if you just thought about the idea that everything's a push and everything does require contact, and so the electrons don't contact each other, they contact a conduit force, and the force has to hit them, and so it moves at the speed of light. It takes time for it to hit them sometimes.
And the probably best known approach to this is string theory.
Oh, which is just silly, right? So the best known by who, and who cares, for what reason. So just a complete nonsense theory about some jellyfish at the center of the universe, that somehow the real universe is a little jellyfish squiggling, these little magical vibrating strings. It's all just such very bullshit. You're just saying, how does anybody take that crap seriously? The invention of a bunch of fake dimensions. I mean, it's just such nonsense.
That most of you will have heard of. There are other ideas like
Yeah, yeah, and even if you heard of it, it never told anything about what it is. It's just a silly mathematical formulation that takes some idea of motion in the universe, and instead of understanding that the motion comes from the outside in, it just creates this idea that the motion comes from the inside out. That somehow the earth just magically vibrates. So it's completely wrong in the sense it doesn't get the point that the earth vibrates because it's got energy hitting it from both directions.
look, quantum gravity, and then there are less well-known ones like maybe asymptotically safe gravity and stuff like this. But so far, we don't know if any of those is correct.
Right, you haven't advanced the ball in terms of a rational, coherent mechanism, a physical mechanism since Newton. So you're instead of being honorable scientists like Newton and saying you don't know what the fuck you're talking about on the subject, you really don't have any idea. Just get out of the way, and and because frankly, it's not that hard to figure it out. Push a verse is not a hard concept, right? To understand that, yeah, well, whatever's going on in the universe, I'm going to assume there's no such thing as just magical pull. And that's what Newton made the statement. He made the statement, look, whatever this thing is, we can say only an imbecile would think it's magical. That there's no force involved. There's no mechanism involved. Yes, there's a mechanism. We just can't see it. But we can surmise rationally and carefully, or we can just make up crap, okay, and believe it arrogantly. And then sell it and proselytize bad theory.
Or how we can even test them. And yes, I think it's a really big problem. Now, when it comes to my personal opinion on what to do, as I just said, like people have worked on this problem for a long time. It's been known since the 1930s.
Yeah, that's right. And they don't care. But yeah, the problems with quantum mechanics were known the day you invented it in the 1930s, okay? The problems with these theories, the twin paradoxes, the different arguments you could make that just make it look silly, could have been brought up, and were some of them brought up. And yes, there is no resolution. You just say it works somehow. Doing what? Who the hell knows? It works doing what? What exactly has it actually invented? What was invented by superposition? What? I mean, she's even doing videos lately where she's pointing out how, yeah, they're not really, the quantum mechanic, the quantum computer money's starting to dry up, and because, yeah, it's not really producing anything. It's not really going to happen.
Something, so it's definitely not a new thing. And there are lots of smart people have spent their whole life trying.
Yes, Einstein's, and so, yeah, and the problem was Einstein got in the way of Einstein because Einstein created this stupid bent space mechanism that isn't coherent to the energy cycle. And if he would have just figured out that I have to make the physics of, the Eiffel Tower or, a rolling bowling ball, I have to make that physics coherent and connected to the same mechanism that gravity. It's all the same system. And identifying the real single universe. And again, the real universe is, it's empty space with stuff moving the speed of light flying through it and hitting matter that's moving a lot less than the speed of light. That's the real universe. It's electrons and protons in black empty space being hit by force bits. And once you have that, okay, it gets really easy to understand how you build on that foundation and create everything else.
Trying to fix something that they think is wrong with gravity. And I have a lot of respect for all those people, and if they couldn't make it work, I'm pretty sure I can't make it work either.
So that's another Feynman line, and it's just, again, it's bullshit because the only way you're going to make it work is you have to get the garbage out. Garbage in, garbage can function, okay? If the computer has bad code in it, it can't do its function. And so you have to clean your code. And your code has been polluted by fables you should have never believed in the first place. The idiocy of 1/2 mb squared. There's just its whole history, no physical evidence, just wishful thinking. And then wave particle. I mean, if you really analyze what's happening, it's obvious the two sources, the surfaces are point sources. That's what all the geometry is obsessed about. There's no frickin' wave involved, and there certainly aren't waves interfering with each other. Certainly in a single slit, there's no wave interference because there's no way to draw the two waves that are interfering.
So this is why I think it's a better strategy to try and figure out if not there's something wrong with the quantum side of things, that the problems may be caused by us not understanding what quantization means in the first place.
Yeah, that's the funny part, right? Is because the word quantum makes perfectly good sense in the sense that we know there's discrete energy in the electromagnetic field. And, Einstein helped in that department by pointing out that, yes, photons are clumpy. And so, once you accept that the force is a thing and that you can give the force properties, then you can understand the force is what's causing the properties of the electrons and protons. The electrons and protons can't do anything without the properties of the force. It's the fact that they both have to play by they have to have a mechanical symmetry. 2 + 2.
Excellent. Eric.
All right, so this guy says some good stuff. He basically says something like, okay, blah, 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 blah. Thermodynamics, something or other, which is interesting. Well, maybe I'll jump a little bit ahead. But he undoes it all by later talking about all the other crap that physics has made up. So there's no real point.
It turned out to have what are called horizons, beyond which light cannot escape. And Stephen Hawking, I think everyone knows him, of course, is famous for discovering that when you combine general relativity with quantum mechanics, that there are special things happening near horizons.
So all this crap about black holes, blah, 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 just such a waste of time.
And when we take his results and his scientific breakthroughs basically seriously, they tell us that we should indeed rethink gravity, maybe think about how to understand it from a more microscopic perspective. So my answer to the question is, should we change general relativity or quantum?
So he points out that he uses the word thermodynamic. So at least he's conceding in some sense that this is an argument about motion and that you have to account for the motion caused. Now, he doesn't say any of that stuff. He just said the word thermodynamic. And obviously all this other crap he says indicates that he ain't getting his own argument. That if you really thought about gravity as a thermodynamic subject, which it is, which it obviously is involved in the sense that it's obviously giving large objects in space, it's creating insane amounts of heat in them.
Quantum mechanics, I would say that the way I approach this, and actually many of my colleagues, is that we take quantum mechanics as a working theory and then try to understand how the microscopic description of space and time, which sort of directly relates.
So he keeps getting into all that crap, which is just a waste.
The connection with quantum mechanics. Okay?
Okay, and then this guy isn't even a physicist. This is like some channel, the Institute of Art and Ideas. And apparently these are all club members because they all do different seminars where they're talking about different subjects, but it's always the same players. So it's a little bit annoying. Anyway. So, nobody else says anything worth giving.
This is the fastest way to get rid of neuropathy.
If you have neuropathy, pay close attention.
I mean,
I don't even know what neuropathy is.
quantum mechanics. I actually think we do need a better theory than quantum mechanics. And the reason I think this is that, maybe let me first say, I agree with Priya that data has to lead the way.
So this is the joke, right? I mean, physics talks about data, but they think the data can be circular. So, they have some sort of magnetron thing that measures deflections of electrons in some way that's somehow connected to deep inelastic scattering, but I don't know exactly how. But they already know how the machine works, and so they're saying that look, our predictions are exactly coming out to our experiment. Well, they should. I mean, if I should be able to duplicate perfectly, some common phenomenon, like launching something with gravity, and then I can get its velocity, to more and more decimal points, and I'll get an answer that'll be closer and closer. And why is that challenging? I mean, that's not proving your theory of why it happens correct. You're just circularly saying my blueprint of the machine is working the same way as the machine, so I followed my blueprint properly. Well, that doesn't mean you understand why, what gravity is.
Because this is science, right? So we need to observe something and then try to explain it.
So they don't need to observe anything. Again, no one has observed it taking 25 times the fuel to spin something 5 times as fast. It's never been observed. They don't care. They don't need evidence. They believe without it. You haven't observed any entangled photons. You haven't observed anything called a superposition. You haven't observed any of this stuff. You've calculated it. And you haven't even done that, frankly. You've just believed in it.
And I think the same is true for quantum gravity. Eventually, we'll need some kind of observation that we'll have to explain.
So, you can't explain gravity if you can't explain charge, if you can't explain magnetism. It's all it's the same function. It's the interaction between force and electrons and protons. It's the interaction between something that always is moving, always is a propellant, and things that collect propellant. And that's all there is. There's little gnats with wings, and they can stick on you and then make you fly, but they have to fly a lot slower when they're stuck on you, when they're carrying you. There's Sisyphuses and there's boulders, okay? And you can't be moved unless you have a Sisyphus pushing you.
But the question is, where do we look? And for this, you need some kind of theoretical approach that says, that's what we need to look for, this is what we need to test. So just because data eventually will be the decisive factor doesn't mean...
So her disagreeing with the other woman is the other woman wants to look in the big universe for experiments to detect gravity. And Sabine wants to do the little universe, see gravity in a microscope. And but both of them are wrong-headed in the sense that you're never going to see it. You're only going to be able to detect its effects. And right now you have overlooked a huge effect, which is gravity clearly creates an insane amount of heat in the universe. And there's no theoretical mechanism to steal that heat or absorb it and turn it into a bent geodesic. It has to be force in the universe. You gave something motion with gravity. That motion has to be accounted for. It has to have a future. And so it has to have some mechanism to make it back into the pressure that pushes things into planets and makes them hot.
We can just get rid of theorists, right? Okay.
We definitely don't want to be out of business. Theorists, right?
No, whatever.
I mean, our jobs will be in jeopardy if we...
They should be in jeopardy because you're just shit talkers. You just make this crap up. You don't really think about it. Again, where have you seen it take 25 times the energy to spin something 5 times as fast? Where have you seen confirmation of this insipid theory of energy?
I'd throw theory out, right?
Right, so we need both, basically, theory and observation. Now, the issue with quantum theory is...
So again, they keep talking about they need experiments, but they don't pay any attention. They haven't dropped 4 pounds 1 foot and 1 pound 4 feet. They haven't crashed cars. They haven't rolled bowling balls. They haven't done tug of war. They haven't done any experiments that make any logical sense to actually see what happens. They haven't measured the temperature. It's, they haven't sat there and said to themselves, well, how is the temperature in the Earth maintained? Something has to keep fueling it. There's no free furnace. And obviously we can't make insulation good enough to store energy for 1,000,000 years. So obviously it must be constantly fueled. The molten center of the Earth has to be constantly fueled.
Is that this quantization of gravity isn't the only problem. We also have what's called the measurement problem of quantum mechanics.
Same difference, in my opinion. The measurement problem, and they think the measurement problem is something to do with the fact that the measurer is part of the quantum field and some other bullshit. But the fact is that there's no way to escape being interacted with by force. Force is so dense in the universe that you cannot take anything and put it in isolation from the force. And the force is profiling. It is creating a record of your existence. And so you can't escape the idea that you can't be in two places at once, because you'll be creating two force interactions in two different places, and you can't do that. There's no evidence that happens.
Which is pretty much as old as quantum mechanics itself. So it's even older than the problem of quantum gravity. And the issue with the measurement is that we just don't know how it works. So if we use quantum mechanics, we make a measurement, we just say, and now a measurement happens. That's like, and now a miracle happens, and everything changes.
That's not what happens. The theory is that somehow these states are something it exists in, and somehow the only way to measure something is with some human target. I mean, it's as if there's no atoms for the photon to interact with getting to the piece of paper, and only the paper will decide when it's a photon, and there's no other place it's interacting with the universe, when of course it's interacting all the way through. It's just nonsense to think you can escape interactions with gravitational fields, for example.
Changes, and here's our measurement result. And so we know how to apply this theory in the laboratory, because we know.
No, so they don't do it in the laboratory. They do it on a piece of paper as mathematical Forky symbols and whatnot, with abstractions.
Know a measurement when we see one, but we can't explain
Unreal numbers.
what it is. And I think that this problem is going to become more and more important now that we're building quantum computers and all kinds of, quantum measurement devices, quantum sensing, and all that kind of thing. So this is where I think the data is going to come from.
So there ain't going to be any data, okay, because it's obviously all they've quantumly created is noise. They've made noise. They have a computer that makes a perfect noise, okay, amount of noise. Not that it makes anything coherent. So the fact is, yes, it produces noise better than we can engineer noise. So if you deliberately try to make a noise, you can't do it as good as a quantum computer, because it's perfect at it. But that's all it's perfect at. So it's like having something that, can make a perfect stink. Why do you want something to make perfect stink?
Stumble over it sooner or later, whether they want to or not.
So none of that will happen, because, again, all of their theories are broken by obvious flaws. There is no hard, good evidence that any such thing, any such formula as 1/2 mv squared has anything to do with reality. It doesn't land people on the moon. It's not the physics that landed on the moon. It's not the science that gets right answers. And that's what all of their physics is made out of, is formulas that are wrong. They're incorrect. They're not accurate. They're not the truth. They're not describing the truth.
Your own work on quantum gravity, would you give the audience a very brief explanation on how to understand or conceptualize quantum gravity in this context for the debate?
Yeah, well, okay. So, you know, when we talked about the introduction that you would give, I had him strike out the word theoretical in front of physicists because I don't really understand myself as a theoretical physicist. I work on phenomenology. And this is what I've worked on when it comes to quantum gravity. I've worked on the phenomenology. The reason I don't call myself a phenomenologist is that no one knows.
So why would somebody make a distinction between those two things, frankly? I mean, there's nothing prohibiting a theoretical physicist from recognizing that watching phenomenon is a good way to glean information in developing theory.
That's what it means. So what it means is that we're trying to make a connection between theoretical approaches and how you can make an experiment. And that
So they think the job of the theoretical physicist is to describe the experiments that will prove their wacky theories, is all really pursue. And they don't bother pointing out, well, maybe we ought to just drop 4 pounds 1 foot and 1 pound 4 feet and see if they make the same size hole in the ground. You know, but anyway, so enough. And such. So, but yeah, there's just nonsense. Every single subject, they make a horrible mess out of it. It's a really simple universe. It's push, it's mechanical. You have to have things, and the things have properties. They have attributes. They're doing something, right? And so the force is moving, and the atoms and the electrons and the protons are just saying, move me, hit me. And I'll do exactly what you hit me, and I'll do exactly follow these rules about either absorbing it, reflecting it, or converting it. And I will function by these simple rules. And that's all the universe there is. And there's no other stories. There's no superpositions. There's no entanglement. There's no any of this abstract bending or warping of space. There's no frames. There's no time dilations. There's no any of that crap. It's a three-dimensional universe full of objects on straight line trajectories, period. And if it looks like a curve, it only looks like one. It's not really curving. That's why pi can't be resolved, because there's no such thing as a real curve. Anyway, it has to be made out of forces, forcing a change. All right, anyway. It's always a bunch of little straight lines. Okay, anyway. So, yeah, enough. Just disappointing. People are just so full of crap and such. And you can't get to them. You can't oblige them to deal with valid arguments pointing out how they're just selling a religion. It's a bunch of junky, silly axioms, declarations about what the truth is and what happens in the universe, and they're not proven and they're not substantiated by any credible evidence, and it's just their personal religion. Yuck.